AWS Lambda using the Serverless Framework. Let's break that down. So serverless computing is the execution model. Python is the runtime on the platform, which is AWS Lambda. Serverless Framework is the toolkit for developing and deploying your serverless functions. So my name is Ted, and you're listening to a TED talk right now. So I'm a software engineer at Tribe. We're an influencer marketing startup based in Melbourne, and we have an office in Ortigas, and we're hiring, so you can ping me if you want. I'm a former software engineer at freelancer.com. Nikki Reyes, one of the co-founders of Pycon Philippines, is my former colleague there. Galleon.ph and YOYO Philippines. I'm an active member of Python Philippines, so I try to attend meetups from time to time. I'm also a committee member of Philippine Tech Hackers. We're not hackers, we're tech enthusiasts, so shout out. So we're hackers. Join us at Slack, we congregate in Slack, so just sign up. And I also draw Filipino webcomics if you're into that. All right, a little something about our company. So Tribe, we're an influencer marketing startup based in Melbourne. So we have a mobile app called Tribe on iOS and Android. So if you're an influencer with at least 3,000 followers and you're based in US, UK, or Australia, you can sign up in our platform and collaborate with brands so that you can earn money with social media content. So you can sell your license to them of your content, or you can post your content endorsing their products or services on your social media accounts, and you can get paid for that. Okay, so check us out at tribegroup.co, and it's a part of the data team. So the data team, we take care of the data analytics, business intelligence, some machine learning. Actually, we worked on a recommendation engine so that we can hook up influencers and brands with similar interests. So yeah, so my primary role is to do the engineering stuff behind the scenes to make the lives of our data scientists easier. So I work with data scientists. I'm the engineering side of that. And I hope I'm doing a good job in making their lives easier. All right, so we're going to talk about the basics of serverless computing. So what is serverless computing, and how it compares with the traditional server-based architecture. And then what else, the key benefits and the considerations before venturing into serverless. And then AWS Lambda, which is one of the leading platforms of serverless computing. And then the Serverless Framework, which is a toolkit for deploying into your provider. And then bringing them all together, AWS Lambda Functions on Python 3 runtime using the Serverless Framework. All right, I'm not an expert. I'm just your everyday software engineer. I just want to talk about our experiences so far. I've been using Serverless Framework for about 4 months now, and I want to share how it looks like on our end. First, what is serverless computing? From the ever-reliable source Wikipedia, serverless computing is a cloud computing execution model in which the cloud provider runs a server and dynamically manages allocation of machine resources. So it's not literally serverless. So you just don't have to worry about servers. Pricing is based on the actual amount of resources consumed by an application rather than on pre-purchased units of capacity. So they have an interesting pricing model, which I will go into detail later. So again, serverless is not literally serverless. You just don't have to worry about servers. So let's do a quick recap on how to set up a traditional server-based architecture, which I believe most of us are familiar with. So first, we have to create and configure servers based on our business needs. In the old days, maybe you have to procure actual machines. Before that, you have to plan how much memory you need, how powerful your processor needs to be, or how much disk space. And now, maybe you can provision that on VPS like AWS. And then you have to install necessary software, install your operating system, and maybe Ubuntu, then apt-get install Apache if you need a web server. And then what have you? What else? Yeah, manage the server. You have to maintain the server, um, perform software updates or install security patches. And then you have to ensure that your server is fault tolerant and scalable. You don't want your server to crash if you suddenly get high traffic. So you maybe want to set up load balancers to horizontally scale your application. Okay, so in the other hand, serverless computing. Again, no server administration. You don't have to provision servers. No software updates to maintain. No security patches to deal with. Serverless computing is highly available and scalable. So thousands of concurrent requests or executions of your function per second. It's not a big deal for serverless computing because your provider should be able to handle that. Pay per execution, you don't pay for idle. For example, in your traditional web application, you provision the web server with 100 gigabytes of memory, and during non-peak hours, your web application only uses 10 gigabytes. You still have to pay for the 90 gigabytes of memory not being used, so that's a huge waste. So on serverless, you only pay for the execution time and the resources that your serverless function is using. All right. So that means it's cheaper, not only because of the pricing model, but also because you don't have to worry about servers. Server management incurs overhead costs, so there. And also that means increased velocity. So this shortens time from idea to production. So it's kind of ideal for startups. Fast iterations of feature deployment. All right, because you don't have to worry about servers, right? You focus on your code at a lower cost. So that's awesome, right? So let's try to convince our team move into serverless right now. What can go wrong? But of course, there's considerations before jumping into the hype train. Serverless is an immature technology, so Amazon Web Services pioneered the serverless movement back in November 2014, so it's just barely 5 years ago. So standards, I think, are not yet put into place, really. So, and also that means not a lot of people are familiar with the serverless paradigm. So you have to factor in the learning curve of your teams. Maybe most likely that a lot of them are not familiar with serverless. Stack compatibility, maybe you have a monolithic Django application. You can't just migrate that into serverless. Vendor lock-in. So at our company Tribe, we chose AWS Lambda to provide for our serverless computing needs. So we put a lot of trust in Amazon Web Services to not mess things up on their end. Platform limitations. So each provider has their own limits on their serverless computing capabilities. I will go into detail more on that later. Local development is tricky. In the traditional server-based setup, it's easy to replicate production-like stack on your local machine. For example, you can have VirtualBox and Vagrant in conjunction going on. Maybe you can have a Vagrant file and spin that up. You can have a production-like stack, or maybe, of course, a Docker setup. You can just whip up a Docker container. You guys already know about that. But for example, you have a Lambda function that gets triggered by a DynamoDB insert on AWS Lambda. It's not straightforward to just replicate that on your machine. I think there are ways like using local stack, but for me, it feels hacky. All right, next, what is AWS Lambda? Again, they are one of the leading providers of serverless computing. Amazon Web Services pioneered the movement, so the serverless movement, by launching Lambda back in November 2014, and then Google followed suit with Google Cloud Formation Functions, Google Cloud Functions, and Microsoft with Azure Functions. So, any of you guys watch Rick and Morty? And so, Lambda functions are like kind of like Mr. Meeseeks, because Mr. Meeseeks craves death. And Lambda functions are not meant to last for a long time. Lambda functions in AWS has a maximum execution time of 900 seconds, so that's 15 minutes. So, like Mr. Meeseeks, it serves a single purpose and then it has to vanish. So let's create a simple Lambda function on AWS Lambda. Right, you can see my demo here, but anyway. So here in the dashboard, let's create a hello world function. Of course, we can choose our runtime here. So we can choose Python 2.7 or Python 3.7. Let's choose a existing role. And then there you have your Lambda function. And here in this interface, you can add your triggers. If you want your Lambda function to be triggered by an HTTP request, you can choose API gateway here. Configuration required. Let's configure that we have an existing API, so we can use that. Let's try adding that. Oops. Default. Oh, wait. Open. So our API is open to the public. I hope I get things right. All right. So there. Oh, there it is. We have an endpoint. You can access that right now, and you can see a get response, get a response from a get request. So you can actually see the code here. This is a built-in code editor on their web interface. You can even use Vim emulation here or Sublime, and you can use their, what's this? I like solarized dark theme. You can use light theme, but what's wrong with you? So there, you can, hello, Pycon 20 APAC 2019. So let's save that. And then let's check out our Lambda function. So there, with just a few clicks of the mouse, you can easily create a Lambda function. This is scalable, and you don't have to worry about it running thousands of executions per second. I just want to delete this. All right. Okay, so events that trigger AWS Lambda functions. You can have your Lambda function listen to upload events on your S3 bucket. And you can have it listen to updates on your DynamoDB tables. You can listen to Kinesis streams, so you can have a pub sub going on. You can listen to notifications. And like I demoed earlier, you can listen to API gateway requests. And you can have your function run periodically, like every 15 minutes or so, using on CloudWatch. Okay, common use cases of Lambda functions: automatic image resizer. So you can have your Lambda function listen to image uploads on an S3 bucket, and then have your Lambda function resize your image into different file sizes, or different dimensions for consumption of different device displays resolutions. ETL jobs. So I think this is one of the most common use case in our company. So ETL stands for extract, transform, and load. Um, in Tribe, raw data can come into our DynamoDB tables, and Lambda functions can listen to those events, and then extract those records and transform them into more into more, how do you call this, into our Redshift tables, so that the data scientists can consume those, can just query into our Redshift tables, which is our data warehouse. IoT applications, for example, you have a hydrophonic setup at your home. You can have your IoT device sensors. For example, you have a sensor that measures the humidity. If it, you can set a threshold maybe, and then if it exceeds a threshold, you can fire a Kinesis stream event, and then your Lambda function can do whatever it wants to that event. Mobile backends and web applications. So like I demoed earlier, a simple endpoint. You can create endpoints through API gateway, and you can have API keys generated also. So you can at least put a level of a layer of security there. And like I said, it's highly scalable, so you don't have to worry about a bump in traffic. So next, what is Serverless Framework? So actually, let's go to their website first. All right, they claim to be the most widely adopted toolkit for building serverless applications. They support these backends. So we also have Kubernetes here. They also support IBM OpenWhisk. Yeah, they're trusted by Coca-Cola, so that's nice. EA Games, Nordstrom, Expedia, routers. So yeah. So they're a CLI based toolkit. So npm install serverless. Don't hate on me. It's JavaScript, but it's an awesome tool. You can create your serverless function and then choose a predefined template by Serverless Framework. So in this example, we choose the Hello World example, but that's in JavaScript. So you can also deploy it in a single command. Behind the scenes, Serverless will use CloudFormation to deploy your resources on AWS. And if nothing goes wrong, you will see an endpoint in the end of the logs here. You have to make sure that you have the proper permissions on AWS to do that, like ability to create Lambda functions and access to CloudFormation and whatnot. And then if you're done playing with that, you can simply do serverless remove. It will take down all of the resources that you created on AWS. So why is Serverless Framework? For me, the biggest reason is that they have 28,000 GitHub stars. So personally, sometimes I'm biased with GitHub stars. I tend to choose the one with more stars. Just kidding. Serverless Framework allows you to stay in your terminal. Like I demoed earlier, do you really want to go to their interface to create Lambda functions? Of course, you want to do that in your terminals, right? As of our developers, you want to stay in our terminals. Platform agnostic, you can do this. You can use Lambda, Microsoft Cloud, Microsoft, Google, and other platforms. Minimum configuration, you can have your serverless application defined in a single serverless.yaml file, which I will show later. Robust ecosystem, like I said, they have 28,000 GitHub stars. That's a good metric, I think, that the community is thriving. So the Serverless Framework community, they've made plugins to extend the functionality of Serverless Framework. There are also examples to look at, and if you have any issues, I'm sure you will stumble upon a Stack Overflow page for that, so that's nice. So you don't have to reinvent the wheel. Application lifecycle management. So you can have several stages, you can have your development environment, staging and production. That's easily configurable in Serverless Framework. And also you can roll back into previous deployments if you mess things up. So that's automatically handled behind the scenes by serverless. Streaming logs, for example, if you want to watch the logs of a specific Lambda functions, you have to go to CloudWatch. So you have to go to CloudWatch and see the logs here. So in Serverless Framework, you can do that in the command line. You can see the logs in the command line. Infrastructure as code. There's this section in the serverless.yaml file, which is the configuration file, that you can define the resources that your serverless application needs. So you can define S3 buckets, and you can define DynamoDB tables in this section of serverless.yaml file. It's a valid CloudFormation template. So if you're familiar with CloudFormation, you should have any problems with that. Yeah.
Is also the AWS SAM for the
Oh yeah. You can follow that structure. Yeah.
Serverless application model.
Yeah, I think I dabbled into that before, but I haven't seen the connection yet. So thank you for that. I'll check that out. All right, so you don't have to type in serverless every time. You can just use the shorthand alias of SLS. SLS info shows the information about the service. So for example, if your serverless application has multiple Lambda functions with several API gateway endpoints, you can see the endpoints through SLS info and also their API keys. And you can also see the number of resources that it's using, it has deployed on Amazon Web Services. SLS deploy. So if you only run SLS deploy here, it will deploy the whole serverless application and all of the resources. But you can specify which function also if you want with the -f option. And you can choose the stage. So here we're launching into production, and you can choose the region on AWS. So here you can stream your logs. You can tail your logs, so you don't have to go into CloudWatch anymore. You can just use this. All right, so here's a basic example of a serverless.yaml file. So here we have a service called hello, and we chose the provider AWS with a runtime of Python 3.7. Which is the default stage. You can have any value there that you want. Maybe your company has a UAT, user acceptance testing stage. You can put that there, which is something that you can override in the deployment, in the deploy command. And you can define your environment variables in this section. These environment variables will be shared by all of your Lambda functions defined here. But if you have environment variables only specific to that Lambda function, you can also define them in their respective sections. Packaging rules. So the way serverless works is that it compiles your serverless application, your local machine, into a zipped folder. It compiles your dependencies and then uploads that into S3, and then uses CloudFormation to create the resources. So you can exclude some folders such as tests, so to reduce the size of your deployment packages. And then in this section, here are your functions. So we have a hello function here. You ought to use a better name here. And the handler field determines which Python function is the entry point of your Lambda function. And then the events that can trigger your Lambda function. So you can have several events that can trigger your Lambda function. Here we have one. So we have an HTTP endpoint with a GET request. You can have it maybe run periodically. You can define more events here. So that's a basic serverless.yaml file. And like I said, there's this, in the serverless.yaml file, you can have resources. You can define your S3 bucket here. You can have a DynamoDB table. You can even prefix your bucket, your resource names in, sorry? 15 minutes? You can prefix your resource names with a stage, so you can have production.s3 bucket, blah, blah, blah. So this is a valid CloudFormation template. Syntax. So here are some caveats when dealing with Python on Serverless Framework. So Serverless Framework doesn't install dependencies from requirements.txt out of the box, so yeah, keep that in mind. And some dependencies compiled on a non-Linux machine might not work when deployed on AWS Lambda. I learned this the hard way. For example, I encountered this with the cryptography module. I compiled it on on my machine, then uploaded it on S3 and on Lambda, and then it doesn't work there for some reason because I did not compile my Python or my cryptography module on Linux machine environment. So a workaround for that is compile your dependency on a Linux environment. Maybe you have a Docker instance or container. So there's a plugin for that, serverless Python requirements. So you can just run SLS plugin install, and then it will automatically insert that into your plugin section. So with that, you can have your Lambda function. You can have serverless automatically detect your requirements.txt file. And to compile your dependencies on a Linux environment, you can set Dockerize pip and set it to true. So this will this will compile your dependencies on a Linux environment from a Docker image. Or you can even set it to non-Linux. So maybe you're compiling your serverless application in a Linux machine. You're already using a Linux machine, so it won't bother Dockerizing it anymore. So Docker image, you can set your custom Docker image to compile your serverless application. All right, I think we have the basics down. I think we're ready for a little demo. So we have an hashtag sentiment analyzer. I made this last week. So it works like this. So I worked on my machine and I deployed using serverless, and it created all of these. So we have a tweets fetcher that fetches every 10 minutes from Twitter API. My keys are it's somewhere in AWS, so I don't have to commit my keys on Git. And then it inserts the fetch tweets related to the hashtag, by the way, into the fetch tweets table, and then it triggers and this Lambda function listens to inserts in this table. So this Lambda function gets the sentiments of those tweets by calling the AWS comprehend service, and then inserts those analyzed tweets in the analyzed tweets table. And then this Lambda function listens to this DynamoDB table, and then it just fetches all of the tweets, and then generates a web page using Jinja template system, and then inserts that into S3, which is configured to display a web page, which is publicly available on the internet. So yeah, it looks like that. I think I could have just used one DynamoDB table, but maybe next time. All right. So here you can access the demo using bit.ly/hashtag sentiment analyzer. So if you want to check that out, so here we're listening to the Pycon APAC 2019 sentiments. You can see the sentiments here. Apparently they're neutral. They're neutral. I don't know why. I don't know. It's AWS comprehend. I don't think they detect emojis. This is positive, right? Anyway, oh, here we have positive. Full house. Congrats. All right. They're neutral. Oh, positive. We have three hearts maybe. So. So there. Here. All right. So I think I need to show the. Yeah, you can see the source code. Yeah. Don't believe that I don't have tests. It has tests, but it's empty. So it's in the to-do list. So yeah, you can check that out. Let's see how it runs in AWS. So I'm thinking, where's the DynamoDB table? Sorry. So I've tagged my resources to have some sorry. Oh, here we have so all of my resources are tagged with service and hashtag sentiment analyzer. So we can see all of the resources here, but you can also see that on Lambda anyway. So let's see the fetch tweets, analyze tweets table. So here are the fetch tweets, and here are the analyzed tweets. So I'm thinking I can show a demo of the workflow. So I can delete this for now, and then this one also. Oops. I think I should also delete my web page on S3 so that we can start from scratch. Oops. Delete. There. All right, so we have a terminal here that I have 3 terminals here that listens to all of my Lambda functions. So I'm running SLS logs for the tweet fetcher, the sentiment analyzer, and the page generator. So on Lambda, on Serverless Framework, you can manually invoke your Lambda function. So with the invoke command. So let's try that. All right. So we fetched 50 tweets related to the Pycon APAC hashtag. So, oh yeah, we've generated the page, and we got the new tweets again. Oops, not this one. Yeah, so there. I can show you the serverless.yaml file if we have time. So here we have the provider. We're using Python 3.6 here because I don't want to download to pull the whole Docker image for Python 3.7. Here are the AAM roles. So actually, let me just show here's the analyze hashtag. It's set in the serverless YAML configuration, and then here are the functions. So if you can see here, uh, the handler points to the func folder and the tweet fetcher, that lambda handler. So it's this one. So and then serverless YAML, and it fetches the API keys from SSM, which is another service by AWS tweet fetcher. There. So there, it inserts to the fetch tweets table, and then the sentiment analyzer listens to those insert events, and then it runs the comprehend service, and then inserts into the analyzed tweets table, and then the results page. If it detects any changes on that table, it will just simply get all of the records there and then put them in a template generate an HTML page using Jinja2. So there, we got a web page, and then the S3 bucket is configured to display a static web page. So yeah, so there, you can see the logs here, fetched 50 tweets, and then the sentiment analyzer saw those insert events. So it has analysis results. You can have more defined analysis here, like their respective sentiment scores for each sentiment. And then the results page generator sees those tweets and then just generates a web page. So yeah, I think that's my talk. So if you have questions, please let me know. Thank you. Okay, so anything? Any questions? Yeah.
How do you manage environment variables?
Environment variables. So
Are those separate service?
let me show you. Serverless.yaml file. Oops. So, for example, I have these. Sorry. I have these environment variables which are shared across my Lambda functions, but you can also define your Lambda function specific environment variables in the environment section in your Lambda function. So here in this Lambda function, it has these environment variables. So there, did I answer your question?
So those are separate. Are those they have the separate services for SSM or?
Oh, you can have your own. You can just key in here you can hard code strings there or whatnot. SSM is just kind of for me the best way to. It's the kind of like a best practices. You don't want to put your keys here. So there. Okay. Yeah, Phil.
Do you think it's possible to make a Lambda function that, for example, listens to a git push and builds a Docker image?
Yeah, I think it's one of the use cases actually. So I think there are integrations where, yeah, you can listen to git push. I'm not sure of the specific ways.
You can install, for example, a Docker command.
Yeah. So yeah, you can have that. I think.
So you can use cost of runtime if you want.
Within your Lambda function.
Within the runtime.
In order to build the image, for example, you need to have the Docker command, right? So can you install that on the function?
Mm-hmm.
You can
Hold
So
on.
you can explore the Lambda layer because it's not group here because
Oh yeah.
you can use your custom runtime group there
Yes.
using Lambda layer.
So yeah, you can. Let's actually check out Lambda right now. Oops. On Lambda, for example, in this Lambda function, you can maybe set up your some of your layers here. So layers, I haven't really explored layers before, but I kind of know the idea. So you can put zip files here, right?
Yes, that's a system.
Yeah, and then you can, so maybe you can have your some of your resources uploaded in a layer so that you can just call them, I think. Correct me if I'm wrong. So
But I think AWS already has serverless tools for building protocols, like AWS Code Build.
oh maybe yeah.
Probably a better fit than
Mhm.
how they do it.
Yeah, code build.
You don't have any. How do you debug your function offline?
Offline. So what I do is I have this debug.py file. So for example, on this, I can I can just import the Lambda function from here, and then I can call the Lambda handler. You can name it whatever you want in your Lambda function, but yeah, I can just manually run it on a debug that on a Python file. And here I have chosen to ignore it on GitHub on my Git excludes.
Is that your real token?
Which one? Oh yes, actually. But it's not in the repo anyway, so you didn't see everything. Right? So it's cut off. Oops, you don't see that. You don't see anything. So for example, you can actually let's try it right now. So IPDB. I got it from Mitch, by the way, the IPDB command. I didn't know that before. Debug. Oops. Debug. So there, you can see the source code, and on line 36, you can see the tweets maybe, or you can format it in a pretty way. So there you can see the tweets that are about to be put in a web page and then inserted to S3 bucket. So yeah, that's how I debug. That's Mitch.
So I use Django.
Mm-hmm.
Can you use Django with Serverless Framework?
No, not really. It's a totally different paradigm. So Django is meant to be hosted on a server. So
What about Zappa? Are those really related?
oh yeah, Zappa is an alternative for serverless, but I think Serverless Framework has more GitHub stars. So just kidding. I think whatever works for you actually.
I see. So Zappa and Django cannot be used as.
I don't think they're compatible, or I'm not sure.
Yeah, you can run Django
With Zappa.
Oh yeah, I haven't explored it, so thank you for answering. So yeah,
Would you recommend serverless for high traffic backends?
yes, absolutely, because
The traffic is really, it's like the traffic is very, very extremely.
like a million requests per second. Yeah, I suppose Lambda should be able to handle that, but maybe for your resources you have to configure your DynamoDB. If you're using DynamoDB, you have to configure your throughput in a capacity that can handle that kind of traffic, maybe. Or yeah, Andre.
Question. So, what's the limitations? Like, let's say, example, high traffic.
Mhm.
Is there a time limit, a size limit, memory limit to that?
Well,
function?
Okay. I haven't explored the actual limits in execution, like how high exactly the maximum. But on the execution time, like I said, it's 900 seconds for Lambda functions. But if you've hooked it up with a API gateway endpoint, on API gateway, the maximum runtime is 30 seconds. So yeah, put that into consideration. You can't have long-running HTTP requests.
Long-running jobs.
Yeah, so yeah, Lambdas are not meant for long-running jobs. So you can maybe look into AWS Fargate for that. So maybe you can have a container that's running continually on Fargate, or on even an EC2 container service, or an ECS, on EC2 container service. So yeah, anything else?
Can we do async in Lambda or serverless?
Async. I'm not sure. I'm not sure. Sorry. Async. Sorry.
Do you recommend serverless for training data in ML?
Well, for machine learning, you need to download models, right? So sometimes models are like huge files. So you have to consider maybe your Lambda function has enough time to download all of that. In a single execution, maybe it will take more than 15 minutes to download and then process everything. So sometimes you can expose an SageMaker endpoint. You can have it on SageMaker.
SageMaker.
Yes, and then Lambda can interface with SageMaker actually. So yeah.
How do you structure the functions?
Oh yeah. You actually have.
Is there a
Mhm.
recommend, like, how do you know?
Okay, so personally, I have a func folder that has all of the Lambda functions that are related to one another. So maybe you can have one folder for each of your Lambda functions. So each of your Lambda functions has its own folder and its own test folder, so that you can compile them individually on Serverless Framework. And actually, where's that package? You can compile them individually. So true. So if you've set that it will try to package your Lambda functions individually. But my current directory setup is not configured for individual packaging. So
Like how big can one Lambda get, like thousands of functions? Or is there a good recommended
what do you mean? What do you mean?
logical split? Should your whole, like if you have a really big application,
Yeah.
is that just one serverless app with 1,000 functions?
Mhm.
Or is there how do you like logically
So-
organize your code
Well,
to something that's maintainable, like especially if you have multiple maintainers,
Yeah.
multiple team members?
So on our company, we've separated we've grouped the Lambda functions that are related to one another. Maybe they're using the same DynamoDB tables or same S3 buckets. So that's one repo on GitHub, and then another repo for another module or another service. So you can have serverless. Each GitHub project can have their own serverless configuration file. So in that way, you can divide you can separate your serverless applications from one another. So is that okay?
Yeah.
All right. Anything else? Yeah.
Any security issues yet that you have encountered using serverless?
Serverless. None that I can think of so far.
Okay.
But
So right now it's inherently secure by default.
so far, yeah. But yeah, you have to make sure that you're not committing your keys anywhere, so like what I did. It's not committed in Git. It's in the excluded list. So yeah. How did I do that? Vim git info exclude. So there, it's not being committed. So so I don't have to tinker with the git ignore file. Anything else? Yeah.
So how much is like, what's the cost for running that?
Oh, that one.
Like, or can you see it in AWS easily?
Oh,
How many?
I haven't checked that. Maybe my bill is $1,000 now. So no, it's supposed to be really cheap. Say AWS Lambda. Pricing. So on Lambda, so you have 1 million requests per month free, and it's priced per 100 milliseconds of runtime. So it's fairly cheap, I think, depending on how you use it.
So you can configure it to have more memory, higher cost.
Yeah. So we will deplete your free seconds per month. Yeah. I'm not the best guy to explain the pricing model actually, because on Tribe I just, you know, well, they have alerts, I think.
You can use the AWS calculator.
Oh yeah, I think they have an pricing.
No, it's like you can search in Google.
Okay, I think they have
Google.
yeah, pricing calculator.
AWS calculator. Yeah.
Simple. You know more about this than me. I'm learning. Simple monthly calculator. I haven't checked this. Oh, so where do I start? Lambda. No, there's not Lambda here. Oh, I don't know. But it's nice to have this kind of thing. But I should check my AWS bill actually. But I'm sure it's not very high right now. Yeah.
Does it have any problem with using different types of DBMS like Postgre, SQLite, because you
Mhm.
may problema ba, may issue ba doon?
I don't think, as long as you're, well, if you're hosting it on AWS Lambda, you can maybe set up your database in RDS. I think that's, well, we have our Postgres database on RDS, and then as long as it's using, yeah, you can use you can configure a VPC on your Lambda function that can access that RDS. So
can you can use Azure?
I haven't explored that.
I think 2 different types of services.
I don't know. Sorry. Anything else? Questions? All right. I think that's it. Thank you. All right.